we have the limit as x approaches infinity of this quantity 1 plus 1 over x raised to the x power. We can see inside of the parentheses that we get 1 plus 0, but it's 1 raised to infinity, basically, when we let this go towards infinity. What does that mean? Is 1 anything 1? Raising something to infinite power, is it going to go to infinity? Is it going to be something in between? We're going to pull a little trick here that may not have been obvious initially to you of what to do, but hopefully you can see why it works. The reason we would want to do this is because we want to see if we can get this x out of an exponent. So we're going to involve a log. We're going to express this as e to the natural log of 1 plus 1 over x to the x. You can see this is equivalent to this because e to the ln, these are inverse functions and they would undo each other and we would be back to what we started with. Now the reason we'd want to do this is so we could use log properties and we could move this out in front and multiply it. So we now have e raised to, we have the product here. Now I have the limit of a function within a function, a composition. It's e to the something. And so I can express this as e to the, take the limit inside and apply the outer function later. So this is going to be x ln of 1 plus 1 over x. Now I'm going to call all of this stuff L just for simplification. So when we get our final answer is going to be e to the L, whatever this L is. But let's go ahead and write down our L down here so we can go ahead and work with the limit part, and then we'll come back and substitute it in when we get an answer. So this is what we've got. And we can see we have the indeterminate form. This one is infinity. If we let this go to infinity, we have the natural log of 1, which is 0. So we have an infinity times 0 indeterminate form, but we know what to do with that. We're going to express this as 1 over x instead of as an x out here, because now we have an indeterminate form 0 over 0, and we could apply L'Hopital's rule. So let's do that. We would have the limit as x approaches infinity of the derivative of the numerator. The derivative of ln of some stuff is going to be 1 over the stuff times the derivative of the stuff. And here's the stuff inside. Derivative of 1 is 0, of course, and we've seen the derivative of 1 over x a lot. We know that's negative 1 over x squared. Now we need to also find the derivative of the denominator. Oh, that happens to be 1 over x, so that's also negative 1 over x squared. Oh, well, that's good. So these will cancel. And now we have the limit as x approaches infinity of 1 over 1 plus 1 over x. And we see that that's going to be 1 because this fraction is going to go to 0. Well, we just found L. So our limit of our original thing is going to be e to the L, or e to the 1. Let's just look at what we just came up with. We started with this limit and we found out that that equals e. It's a way that we could express e. We are going to see this more in Calc 2 when we start talking about sequences and series, but kind of interesting to just see it at this point with our limits and applying L'Hopital's rule. Let's go ahead and look at the graph then. What we just found here was the limit as x approaches infinity of this function then is e. And you can see the graph here, and as we get larger and larger and larger with x, we are getting closer and closer and closer to this number 2.718 and so forth.